The video title is 2.10, 2.11, sorry. And in this video, I will be continuing with the fault recovery. In the fault recovery, there are different phases, that is different types. You can say voting, active redundancy, or you can call it as a hot restart, passive redundancy, you can call it as a warm restart, dual redundancy, or triple redundancy. And SPAY, shadow operation, state of resynchronization. These are the different phases or different tactics, recovery tactics, fault recovery tactics we can apply to fix a fault. Voting. In this process, the processes running on redundant processors each take a equivalent input and compute a simple output value that is sent to a voter. If the voter detects a deviant behavior from a single processor, it fails it. The best analogy for this is, for example, we need to calculate 4 different operations, that is 10 plus 100 and 20 plus 200, 30 plus 300 and 40 plus 400. All these operations we need to calculate via network, and I will put this query, and each query will be addressed by different 4 nodes. That is, here equivalently each node takes input and compute a simple output. That is 10 plus 100 will be 110, 20 plus 200 will be 220, 30 plus 300 will be 320, and 40 plus 400 will be 420. That will be the output. And it is sent to another that is node called a voter. If the voter detects a deviant behavior from a single processor, it fails it. Means there are 2 nodes, they were calculating a 100 plus 10, and another node is 200 plus 20. Instead of what is the first node, that is 100 plus 10, what should be the output? 110. Instead of this, it is providing some other result, that is 100. It is wrong. And another node, that is 200 plus 20, it is providing another wrong output, that is a 200 only. So this error will be detected by the voter, and that is a deviant behavior from the single processor. Fails it. And next is active redundancy. The other name for it is called as a hot restart. All redundant components respond to events in parallel. The response from only one component is used, usually the first to respond, and the rest are discarded. The active redundancy is often used in a client server configuration, such as a database management system, where quick responses are necessary even when fault occurs. That is, in the case of active redundancy, all redundant components respond to events in parallel. Means imagine in a client server architecture there are 10 nodes, and all 10 nodes are active and they are performing their task and they are responding to events. Whatever, let us take the previous example, the calculation of numbers a plus b, b plus c, c plus d, d plus e, like this calculation of numbers will be there, and they are calculating parallelly, they are responding parallelly. The response from only one component is used. Means here actually what they are that is describing that only a plus b's response is used. Usually that is nothing but it is the first to respond, and the rest are discarded, that is b plus c or c plus d or etc. so on, that will be discarded. Because this is mainly used in a client server configuration, because that is more number of clients are invoking on the same server at a time parallelly. So the response should be faster and correct and reliable, and such database management systems where quick responses are necessary when a fault occurs. That is the same calculation of numbers 10 plus 100, 10 plus 100, 10 plus 100, 10 plus 100 will be calculated by many nodes that is imagine 10 nodes and only the first node response is taken. A's response is taken and remaining B to F responses are discarded because this is a mechanism used because if A fails, B's response is calculated. If C fails, D's response is calculated. If D fails, then E's response get calculated. And if F also fails, then other response will be calculated. This is the reason why this kind of fault recovery technique it is called as a active redundancy, or you can call it as a hot restart. Especially in a client server configuration or a client server environment where the response to the client will be provided at a faster rate. In such cases, this kind of fault recovery tactics will be used. Next we move to the passive redundancy. It is called as a warm restart, or another name for it is a dual redundancy or triple redundancy. Let us see what this is. That is one component, the primary component you can say, respond to events and informs the other components, the standbys who are the mutual component to primary component, standbys of a state updates they must make. When a fault occurs, the system must first ensure that the backup state is sufficiently fresh before resuming services. In earlier that is fault recovery, what we had discussed, instead of using a one node, there we are using multiple nodes. In the passive redundancy, it is opposite of that. Active is the opposite of passive, where we are using only two components. One component is a primary component and another component is called as a standby component. And when the first component fails, that is the primary component fails, that will be notified by the standby other component. When a fault occurs, the system must first ensure that the backup state is sufficiently fresh before resuming services. The backup should be taken before restarting other services. And next fault recovery tactics is the spare. A standby spare computing platform is configured to replace many different failed components. It must be rebooted to the appropriate software configuration and have its state initialized when a failure occurs. Spare means it is a standby spare computing platform and it is configured to replace many different failed components. Means this is an extra component that is installed along with the existing component. When any component fails, then that will be replaced by the spare component, and this spare component it is configured with our computing platform so that it has performed all the functionalities that will be replaced with the earlier existing component, and it must be rebooted to the appropriate software configuration and have its state initialized when a failure occurs. It must be stage must be rebooted to appropriate all software configurations, and it can be initialized when any failure occurs. And next fault recovery tactics is shadow operation. A previously failed component may be run in a shadow mode. Means for a short time to make sure that it mimics the behavior of the working components before restoring it to service. Shadow operation means, for example, the best analogy for this is, usually in our house we keep two vehicles. If one fails, then we can use the other. Means both functionalities will be same for use. The usages will be same to reach some place. So when one component fails, one vehicle fails, then we can able to replace with the other component. But the type of functionality, the speed of vehicles will be, the average will be different when we compare both the vehicles. Then also it is somehow replacing the functionality of the earlier vehicle, that is it mimics the functionality of. This is called as a shadow operation. Next is a state resynchronization. In this tactics, the passive and active redundancy tactics require the component being restored to have its state upgraded before its return to service. In this case, both passive and active redundancy tactics require another component being restored to have its state upgraded before its return to service. Means in the active we are using multiple components, in a passive we are using a few components. When these two components fails, in order to restart, in order to restore whatever the earlier functionalities are held with, we need to have its state upgraded before its return to the service. Next is checkup point rollback. A checkup point is a recording of a consistent state created either periodically or in response to specific events. Sometimes a system fails in an unusual way. These are nothing but checkpoint and rollback. These are just the recordings of a consistent state created either periodically or in response to a specific events. For every 10 seconds or when any system fails, that is a response to specific events. Sometimes the system fails in an unusual manner. With detectability in consistent state, in this case the system should be restored using a previous checkpoint of consistent state and log of the transaction that occurred since the snapshot was taken. Means this is a phase there will make a recording of all the functionalities of the module or a component, and a particular module fails at some particular stage. In that case, with the recording we can detect where it has failed. That is, we can take a snapshot and we can make out, instead of starting all the that is fault fixing mechanisms from the initial stage. With this tactics, we can make out at which point the software has failed, which has got different bugs. With the particular that is point, we can recover the software. We can back up the software and we can fix the errors. Next is fault prevention. Fault recovery is over, and next is a prevention. Instead of recovering, it is better to prevent a fault. That is removal from services, transactions, process monitor. These are the three different fault prevention tactics used in a software architecture. Removal from service. This tactic removes a component of the system from an operation to undergo some activities to prevent unanticipated failure. It is a component. Software architecture is a component of components. If any one component among different components is providing a error, then only that component will be removed. That is called as a removal from service. Instead of holding the entire component, entire software components, we will stop only component to be working there. And next is the transactions. A transaction is a building of several sequential steps such that the entire bundle can be undergone at once. The transactions are used to prevent any data from being affected if one step in process fails, and also to prevent collisions among several simultaneous threads access to the same data. Transaction means it is a series of data exchange between different modules. It's a communication between different modules. That is why we can call it as a bundle of several sequential steps. So in this case, in order to prevent a fault, transactions are used to prevent any data from being affected in one step in a process phase. For example, we are transferring the data from A to B, B to C, and C to D, and D to E. And when the data is not passed from A to B, we'll check the two components, whether it is A's component or a B's component.